This will show the assembly language move command using Fasm for 32 bits on Windows. So for the x86 CPU in 32 bits, these are the registers that you have to work with on the CPU. And for 64-bit, the registers would be named RAX, RBX, and so forth. And so now these registers are 32 bits. Each one can store 4 bytes. But the EAX through EDX are made up of parts, and this shows your backwards compatibility. Before the CPUs were 32 bits, they were 16 bits, and the registers were named AX, BX, CX, and DX, and then back to 8 bits. So, and these are the original intentions for these registers, but you can use them pretty much however you want, with the exception that you probably should not mess with the stack pointer or base pointer registers, because those provide a hardware stack and will be used by function calling. So here's my program, and this will be a console program. And I'm including this library right here for the printf, the C function printf, to output to the console. So here is the code section, and here is the data section. I've declared 2 variables, A and B, both of them 32 bits, and set them to 42 and 73. And then here is my imported data section, where I've imported the printf, the scanf, well, I'm not using that here, and then a get character, so I can do a press any key to continue right here. And remember that the labels right here, start and ending, those are whatever that you want to put in there. And those would be used by jump commands to jump to different parts of your program, or you can just use them kind of like I'm doing here for organizing the program. So now the first thing we're going to do is the move command takes 2 operands. The first operand is what you're moving data into. So I'm going to move into this 32-bit EAX register the immediate value of 88. And then I'm going to print it out. So I'm going to print out EAX register contains, and then this one takes 2 format specifiers. %D means the print out a 32-bit decimal number, and %C means print out an 8-bit character. And so then the first parameter I'm putting right here is EAX, which is for the %D, and then the 10, which is a ASCII value for a line return. So that's the %C specifies that. And so now if we run it, this is what it looks like. And so it just prints out EAX register contains 88. And press any key. Okay. So it's important to remember that the registers you have here on the CPU, there's nothing permanent about them. So when you call an external function, the C invoke this printf right here, it will mess up some of these registers right here. So anything that you want to save, you should be putting down into variables, which are, just memory locations. So just to demonstrate this, if I were to print, I'm going to copy this line right here. And so here I'm printing out the EAX register, which will be 88, and then I'm going to print out the EAX register again. And so now watch what happens. So now the first time I printed out, it contains what I was expecting, and the second time I printed out, it contains the number 26. So that EAX register gets messed up just by doing the printf. Okay, now I'm going to take this back out, and so let's just we can just move our registers around. So right again, we've moved into the EAX register, the immediate value of 88. If I move into EBX register, the contents of EAX register, then I'm going to move into the ECX register, the contents of the EBX register. Now I'm going to move into the EDX register, the contents of the ECX register, and now let's print out the EDX register and run it. And so now I'm still getting my 88 in the EDX. So I just moved that value from this register to that one, and that one, and printed out that one. Okay, now we're going to look at using the subparts of the EAX register. So I'm going to get rid of some of this stuff that we just did. And let's move this back to EAX, because we will print that out in a second. Now let's move into the EAX register 0, because I want to zero out the entire register right here. Okay, now I'm going to open up a calculator. Okay, so here's a calculator, the programmer version of the calculator that can give us some binary. Okay, I'm in decimal. I'm going to type the number 240. Notice what 240 is in binary. It's 11110000. Okay, now I'm going to move into I'm going to move that 240 into the AH register and the AL register. But let's first just move into AL register 240. Okay, so now the first 24 bits should be 0, and then the last 8 bits will be the 11110000, which is 240. So let's print out the EAX register, and we get our 240. Okay, so you can see that even if you move stuff into the AX, AH, or AL register, those are actually subparts of the EAX register and will change the contents of it. Okay, now watch what we do now. I'm going to move into the AH register 240 again. Okay, so now this one contains 11110000, and then this one contains 11110000. So let's see what that looks like on the calculator. I'm going to click on binary, and I'm going to do 1111. That's too many ones. 1, 2, 3, 4. And now let's do it again. 1111 110000. Okay, so here is 240 that's in the AH register, and then here is the 240 that is in the AL register. But now if I print out the EAX register, it's going to treat this as one number, which you can see is 61,680 right here. So let's run the program and see what we get. 61,680. Okay, so now I'm going to get rid of these. And so now let's look at our variables right here. We have variable A, which contains 42. So if I move into EAX, you need to remember to move the contents of A, because A is a memory address. And so if you do A, you're actually specifying the memory address. If you put the square brackets around A, then you're specifying the contents at that memory address, which will be 42. So let's run it, and so it outputs 42. But now, if I were to not put the square brackets and run it, you'll see that now I get a memory address right here. And since memory addresses are sequential, so when you declare this, it will reserve 4 bytes to store your 42, and then when you declare B, it will restore the next 4 bytes to store 73. So again, if I did square brackets, that will print out my 42. But if I add 4 onto that memory address value, then see what we get. We get our 73. Okay, so this is essentially how arrays work. When you declare an array in a higher level language, it's just sequential memory addresses that stores your values. And so then you've got your, I guess you could call that your index number right there. Now let's talk about moving data into memory. So let's say that we want to move into variable A. You need to remember to put the square brackets. And so you're going to move 88. And so then when I print it out, put put the square brackets to grab the contents of the memory address. And let's run it. And there it is. Prints out the 88, except it's not EAX register, it's actually A. Contains that. Okay, now here's the thing though, is that if I tried, let's say I want to copy variable B to A. I want to copy the 73 into A, and overwrite the 42. If you try to move into A the value that's at B, you'll get an error. And so the error is invalid operand. So the assembly language does not allow you to move from one memory location to another, or one variable to another. So if you want to do that, you're going to have to go through a register. So I'm going to move into the EAX register the value that's at B, and then move into the A variable, the contents of A, the EAX register. Okay, so now I've essentially copied the 73 and overwritten the 42 into A, like that, 73. And that will get you started on moving data around.